go do that again. So what's the area of the red here?
6.
And the area of this is?
4.
Okay, and hopefully what you see is that 2 times 3, we're going to use a dot for multiply, plus 2 times 2. Those numbers are coming from the dimension. This is 2, that's 3. Do you see that?
Yeah.
And this is 2, and that's 2. 2 times 3 is 6. That's where the 6 comes. And the 4. And so we know the area of those 2 rectangles add up to 10. Raise your hand if that makes sense. Okay, you got to look at me, though. If you're looking at the table, then you're just raising your hand. But you need to watch. So over here, what's the area of this whole picture? The whole thing, the red and blue on the right. It's 10, right? So this is an area of 10. Okay? So the area of this is 2. And then, how long is this?
5.
It's 5. Count them, right? 1, 2, 3, 4, 5 squares, right? And so it is 5, but it's also 3 plus 2. Do you see that?
Oh, yeah.
And so another way to think of that is 2 times 5. It would make sense to add the 3 plus 2 together. Does it make sense to you? Can you see that from the picture?
Mm-hmm.
And so that's equal to 10. And so you see that you get the same thing doing the problem 2 different ways. So what I want you to see over here is there's 2 separate rectangles and 2 separate area problems. Right? Length times width plus length times width. Remember area from elementary school?
Yes.
Over here there's only 1 rectangle, right? So when we put the length outside and put it next to parentheses, that's probably new for most of you. You should probably look up instead of pointing to your little chips and towers, right? So when you see something like this, what that means is the outside number 2 times whatever the inside number adds up to. It's called the distributive property. So before we talk about it a little more formally, I'm wondering if you can use your chips to model. So take the blue and red chips and see what you can come up with. I'm obviously not doing it for you down here for this problem. So how can you make a picture of that? A rectangle picture. Using blue and red chips. So take 3 minutes to do that. So stop, look, and listen. Hands off the tiles. I've seen it on a lot of tables. I don't see it on every table yet. Did you take it apart?
Yeah.
Okay. So describe, Walter, what yours looks like. Like if I were going to build this, tell me what to do. Two columns, nice use of your vocabulary, of 3 reds. So a column, you know, is like a pillar, right? So I'm going to take 2 columns of 3 reds, okay?
Then 4 columns of 3 blues.
And then 4 columns, and are they going to be stuck together or not? You stuck them together? So 4 columns, see if I can catch that, of 3 blues. Yeah, go away. Okay. Okay. And why did you stick them together? I'm just curious.
Because it says 3.
So there's 3 times the 2 plus 4, which is really 6, right? 2 plus 4 is really 6. Okay? So if I take his whole picture, my question to you guys is how can you write it a second way with this picture. Hey, Max.
Can I come up?
No?
Well, so make it a different way.
Yep.
Alright, you move the first blue column.
No, make it like the new picture, not the picture on the left, but how do you write the equation for the picture on the right?
Oh, you could do, 6 times 3.
No,
6 plus 3.
not quite.
6 minus 3.
No, how about Avery?
You go 2 times 3.
So you have your 3 here still, right? And your 2 here. So that's an area of 6, right? Just like the red over here. So she's saying you could do 3 times 2, right? What else, Avery?
Then for the blue block, you can do 3 times 4.
Plus, which would be 12, right? Plus 3, and I'm going to go back to the dots here because the times, I want you guys to get used to seeing that dot for multiply. And so that means that if she's right, these should be the same. So if I look at this rectangle on the left and think about the area here, I'm going to have 3 times 6, right? What's that equal to?
That's what I said. 3 times 6.
What's 3 times 6 equal to?
18.
18, right? So, and then what is 6 plus 12 equal to?
18.
18. So on this side, the way you would work that problem out by is you would do what's in parentheses first. Does that make sense?
Yeah.
And when the numbers are next to each other, you multiply them. So we have 3 times 6 here, and with 2 different ways, we get the area of those rectangles, okay? This is sort of like the introduction to something called the distributive property, which you have to use for your homework today. So if you take your book and turn the page, you're going to write some notes down. Okay, so I'm going to pause for a minute while you guys get that. If you turn the page, you're going to see some rectangles. So I'm going to skip over a page. It says in each diagram below, do you see the directions there? This is on page 68. And it has some pictures.
Oh, yes.
Can you find it? And you have, number 1, you have like a horizontal rectangle. And it has a little dotted line in there. And I'm going to just kind of make the picture a little estimated. And there's how many squares right here? From here to 4, right? And how many from here to here? 5. And how many from here to here? 7, right? And it says in the diagrams a large rectangle has been divided into 2 smaller rectangles. Do you see them?
Yes.
Okay. For each expression, show 2 different ways to calculate the area of each rectangle. So on your note sheet, you don't have to draw the pictures, but you can label it problem 4.2. So when you go home, you have some samples. So the 2 different ways you could write the area for this are, Sebastian, give me one.
You could write it by saying 5 by 11.
So 5 times, and I'm going to write it in what they call factored form. I actually want you to write it like this first because you want to get used to seeing it that way, but you're exactly right. So factored form has parentheses. And then you would work it out, 5 times 11, right? Which is 55. And then Sophia, what about the other way? What would be another way to do it?
Other way.
What's that the same as, in other words?
5.5.
5 times 4, right? Right, 5 times 4 for the left rectangle, and 5 times 7 for the right rectangle. These should turn out to be 55, right? What's 5 times 7?
35.
What's 20 plus 35?
55.
So there's 2 different ways to find the area. Raise your hand if that makes sense. Okay, that's the first type of problem. You understand that? Second type of problem, you can write right below your picture, is you should be able to take this without the picture and sketch a rectangle. So each of the following expressions, here's an expression, it represents the area of a rectangle. So you should be able to draw that rectangle. So it's the big rectangle, because if you look at the other side of the page, it's not the factored form, it's what we call the expanded form, where it's got no parentheses. See, the expanded form has 2 parts? So you're supposed to take that factored form and draw a picture of it. So this, would that be the width or the length? Like, would it be the vertical part or the horizontal part in this picture? The 3 would go here, that's right. And then I would have to do a little division line. And what is the distance from here to here?
3.
Good. And what's the distance from here to here?
6.
Right. Okay, so this is 3 times 3 in here. Do you get that?
Right.
So that would be 3 times 3. And this is 3 times 6. And so we've sketched a rectangle and we've written an equivalent, that means the same, expression for the area of the rectangle. That's what your homework's like, okay? It's on the board there. It was originally a Wednesday homework that I moved to Thursday. If you get stuck, you can do what? Come in the morning, but first maybe watch the video tonight, right? Because the morning doesn't have enough time to redo everything. So if you get stuck, first try watching the video. I'll post it. Okay? And then work hard on that as you can.
Bye.